verify that the following function is even. An even function is a function that's symmetric about the y-axis, and it has this relationship down here. A common example that you should be familiar with is a parabola. So if this is the y-axis and you imagine drawing a bit of like a reflection line, and if you reflected it across, it should be perfectly symmetric. So a parabola, when it's centered, is an example of an even function. So a way that you can verify if a function is even is by checking whether it obeys this relationship that defines an even function. So for this question, it says verify that. So we'll start with doing f of negative x. So f of negative x, which means replacing every x with negative x to the power of 4 minus 2, negative x to the power of 2. And after a bit of working, we should be able to then verify that this is the same as f of x. So it's equal to the right-hand side of this rule. So let's go. So if we do negative x to the power of 4, the negative gets cancelled away because of that even power. So to really fully show it, I'm going to do it separately. So I'm going to put the negative to the power of 4 out the side, and then I'm going to do the same thing here. So the negative to the power of 2 out the side, and then x squared. And then for each of these, I can show that that's times 1 because the negative gets cancelled off. And then that's equivalent to just 3x to the power of 4 minus 2x squared. And if I have a look, that's exactly the same as f of x. So now I'll say f of x. And then I can say, therefore, f of x is an even function. Okay, so all I've done is I've gone and proven that this holds true for the function f of x by doing the left-hand side, and then I evaluated, I did some steps, and then I proved that it's equal to the right-hand side of the relationship for an even function.